fire is to use water. You can see how water removes the heat using a balloon. The balloon is a fuel. Fill it with air, bring a source of heat towards it, and it bursts immediately. But fill it with water, and nothing happens. Why doesn't it burst? To successfully put out a fire by taking the heat away, you first need to find the heat spot. Sounds simple enough, but it isn't as easy as you might think. This is what firefighters experience when they enter a building on fire. It's pitch black and it's smoky. The only way they can see what's happening around them is to switch on a thermal image camera. Thermal image cameras work by showing up heat spots in white and cold spots in black. The camera quickly picks up the heat spot they're looking for. A burning sofa. Once they've found it, the firefighter with the camera is the only one who can see it clearly. He has to help direct the other to put it out.
Down a bit. Down to your right more.
The jet of water appears black.
Your right.
You can see its cooling effect straight away. The sofa changes from a hot white image to a cool black one.
Okay, stay there.
And the fire goes out.
Stop with that, Carl.
In parts of the world like Canada and America, where there are massive forest fires, removing the heat with water is essential. Firefighters drop thousands of litres of water from specially designed planes, in a mission to cool down and put out the burning fuel below. It's a mammoth task. But when would putting out a fire with water be a bad idea? Chip pans and hot oil are one of the most common causes of household fires.
This is what happens when we put just an egg cup full of water onto the fire.
As the liquid water touches the hot oil, it becomes steam, expanding 2,000 times and carrying the burning oil with it. It's dangerous to tackle a chip pan fire yourself. The fire brigade's message is, get out, give them a call, and stay out. So how do firefighters deal with oil fires like this?
The correct way to put this kind of fire out is to use a fire blanket.
What's been removed this time? Heat? Fuel? Or oxygen? The blanket cuts off the oxygen supply. No oxygen, and the fire goes out. Using a candle in a tank of water, you can see what happens to a flame when the oxygen supply is limited. As a candle burns, it uses up the available oxygen and then goes out. Water takes the place of the oxygen, so the candle rises. It can't rise any further because only a fifth of the air is oxygen and the rest is mainly nitrogen. With some fires, removing the oxygen is the safest approach. On large oil fires, foam is used. Foam floats on the top of the oil, coating it like a blanket, so the oxygen can't get through. With the risk of an electric shock, electrical fires are never put out with water. Carbon dioxide is used instead. Carbon dioxide is a dense gas which covers the fire, again stopping the oxygen from getting to it. But with so much oxygen, it's very difficult to limit it. Even when firefighters think a fire has gone out, it only needs a fresh supply of oxygen to start again. Look what happens when the door of this smouldering house is opened. To fight fire, it's usually the heat or the oxygen that's removed. This is because it's very difficult to take the fuel away. But with forest fires, removing the fuel becomes essential. To stop the fire from spreading, surrounding trees are cut down to make fire breaks. In this way, a further fuel supply is taken away. So it's only by understanding the fire triangle that fire can be controlled. Fire can also be used. With careful control of the three ingredients, it can be an important tool.
Okay, diver comes check.
Surface diver, come check, let it clear, Harry.
Divers are able to use fire for cutting through thick metal plates. It's a very skilled and controlled process. This hollow steel rod is actually the fuel.
Can we just do an oxygen pressure test, please?
Roger that.
Oxygen is provided direct from a tank to the hollow interior of the fuel rod.
Ready to make it hot when you are.
Roger that, ready to make it hot.
An electric arc produces a spark which provides the heat. The heat generated by the fire is so great that even though the flame is surrounded by water, it doesn't go out. The steel rod is burning. It's so hot, it can cut through metal, so thick.
Okay, making it cold, power off.
Got to cut it off.
Roger that.
It's dangerous work and needs plenty of training to get the balance of fuel, oxygen and heat just right. Cars also use fire. Again, the amount of fuel, oxygen and heat has to be carefully controlled. This happens inside the engine's cylinders. As the piston moves down, a mixture of fuel and air is drawn in. The piston moves up and a spark causes the fuel to burn explosively. The exhaust gases are then forced out. The energy released by a series of small explosions causes the pistons to move up and down, driving the car forward. Petrol is the most commonly used fuel in cars, but it's also highly flammable. Petrol ignites easily. Look again, and you'll see the match doesn't even touch the liquid before it catches alight. What is it that's actually igniting? Petrol is made up of tiny particles. At room temperature, some of these particles have enough energy to escape, vaporizing into a gas. Petrol vaporizes easily. If you look at a beaker of petrol in shadow, you can actually see the amount of vapor pouring out. It's this invisible vapor which ignites and burns, not the main bulk of the fuel. This driver survived because he was wearing protective clothing, made from specially designed material. The material doesn't burst into flames easily. Why is it more difficult for some things to set alight? This is diesel. Why doesn't it light straight away? As petrol burns, a chemical reaction is taking place. The petrol combines with oxygen to produce new compounds. A good way to find out exactly what these compounds are is to take a car for an exhaust test. The liquid you sometimes see dripping out of the exhaust pipe is water. Petrol contains hydrogen. When this reacts with oxygen, water is produced. A special probe gives a readout of the other products. Petrol also contains carbon. When this reacts with oxygen, it forms carbon monoxide. But carbon monoxide is poisonous, so it's important for the amount in car exhausts to be as near to zero as possible. With this old car, you can see that the carbon monoxide reading is around 4. It's higher than it should be. Petrol reacts more fully with oxygen, carbon dioxide forms. The carbon dioxide reading for this car is around 12. How will a much newer car like this compare? The carbon monoxide level is much lower than the old car. It's nearly 0. The carbon dioxide level is higher. It's over 15. This is because newer cars have catalytic converters. They ensure that any carbon monoxide is converted to carbon dioxide. Both old and new cars are polluting the environment. Older cars may emit more poisonous fumes, but producing more carbon dioxide isn't necessarily the answer. Carbon dioxide is a major contributor to the greenhouse effect. If we didn't power our cars by burning fuels, where else could the energy come from?